Section 2.5, using linear models. Our objectives for today are to write linear equations that model real-world data and to make predictions from those linear models. First, we have to look at what a scatter plot is. Please refer to page 92 for pictures of those correlation strengths. I'll talk about those in a second. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. You'll notice when you look at pages 92, 93, and so on, that none of those dots are connected with lines. We're just plotting data. So a scatter plot means just that, plotting the data, and then we're going to look at the strength of the relationship. Correlation, use the scatter plot that has been graphed to determine the strength of the relationship between the data sets. So when you look at page 92, a strong negative correlation has a bunch of data points kind of close together and you're going down. A weak negative, the points are a little bit more spread out. Wait, I did those pretty close, just a minute. But you can still tell it's going in that negative direction. No correlation. They're all over the place. You can't tell if it's going up or down. And then we have weak positive. So they're going in an upper direction, but they're not very close together. And then we have strong positive. They're pretty close together and they're all heading up to the right in that direction. So please refer to page 92. Their graphs are much better than my hand-drawn ones. So looking at problem 1, the table lists average monthly temps and electricity costs for a Texas home in 2008. It displays the values rounded to whole numbers. Make a scatter plot. How would you describe the correlation? So when you're looking at the data, and you'll have to look at page 93. I can't fit all this onto one screen and still do work. So they have the month, they have the average temp, and they have the electricity bill. So when you are looking at this, you're looking at the data. So the average temp is in that first column. That's going to go at the bottom. And please label what it stands for. And that is in degrees Fahrenheit. We're going to have equal increments going across. We'll do that in a minute. When you look at the second column, it is your electricity bill. And of course, that's in dollars. We'll have equal increments along the side as well. Does it matter that it's January, February through December? Not really. You only get bills once a month throughout the year, so that's kind of a standard. So when you look at the data, you'll want to look for what is the smallest average temperature, what is the biggest, so that you can actually fit them all in. So the smallest looks like it might be 58, and the biggest is 85. So if you take 85 and subtract 58 from it, you get 27. So if you do ones, you'd have to have 27 lines going across, which we don't have. Maybe let's go by fives, or skip a line and do 5. That might work. 5, 10. No, we can't go 5, 10 because we have to be up there. Let's do tens. We could have maybe done 5s and gotten by with that as well. Maybe that'll work better. Let's go 5s. 5, 10, 15, 20, 25, 30, 40, 50, 60, 70. Yep, that'll work. As long as all of your numbers are going to be on there. You are good. So I'm going to go like that to make it look a little bit neater. The electric bills, my smallest number on the left is 139. My smallest number on the right is 110. My biggest number on the left would be 234. My biggest number on the right would be 255. If we subtract those, we get 145. Obviously, we don't have 145 lines. Let's go by 50s. Let's also do a break in the graph. If you don't start with 0, you draw this little zigzag line, like a lightning bolt kind of, to break the graph. So let's go 50. I'm going to go by hundreds, I guess. I'm going to go like this. I'm going to go 100 and go next to the line that it represents. So skip a line, and that'll be 200. Skip a line, that'll be 300. No. We can do smaller than that. Let's do 100 here. And then the book goes by 20s. Let's do that. 120. 140, and again, it's next to the line, not in the spaces. 160, 180, 200. We need to keep going just a little more. This would be 100, 120, 140, 150, 160, 70, 80, 90, 200, 210. This would be 220, 240, 260. And that, I think, should do it. The break in the graph represents, we're going by 20s, but we haven't hit all the 20s up to 100. So that follows through. Let's put a title on there. It's the title on the table that we have. It's average temps and electricity costs. We could put the year as well if we wanted. It was 2008. So that's been a while ago. Now let's put them on the graph. So at 61, it goes up to 150. So 61, we follow it up. It goes to 150. Oops. And we'll put a dot. February is 58, 139. Then we have 67, 172, and we'll keep on going. $75, 205. $79, 170. $83, 234. $84, 255. $85, 245. 81, 210. $76 goes to 183. 65 goes to 132. And 58 goes to 110. Okay. So you get the dots on there. They look pretty good. Let me check a couple of these. I might have done the wrong one. So the one that went up to 1... It was 66 or something like that. 65 goes to 132. That looks okay. Some of the ones that I have off to the right, I'm going to check. 79 was at 150. 170. Yep, that looks good. 81 was 210. That one looks good. Okay, I think they're okay. So the next thing they want us to do is describe the correlation. So as the temperature increases, the electricity cost also increases. The points are relatively close together. So I would say this one is a strong positive correlation. Oops, sorry about that. It goes crazy here. So strong positive correlation. A trend line is a line that approximates the relationship between the variables or data sets of a scatter plot. You can use a trend line to make predictions from the data. Problem number 2, the table shows the median home prices in Florida. What's the equation of a trend line that models a relationship between the time and home prices? Use the equation to predict the median home price in 2020. So when you look at this data, you are looking at page 94. We're going to put the data on a graph, but before we do that, I give you some steps here. Instead of using the years at the bottom, we're going to assign the first year to x equals 0, and they'll usually tell you how they want you to do that, so you can fit them all in. We're going to sketch a trend line. We're going to choose 2 points to find the slope and write an equation. So we can figure out the slope. We can use one of them to find the intercept, and we're going to use that equation to predict the median home price. The thing with trend line is my trend line might be slightly different than yours. So when you check your answers, they might be slightly different, but they should be similar. So just be careful with that. So let's get this graph going. All right, so the X would be the years. Okay, let's do a title first, actually. Florida median home prices. Okay, along the bottom, number of years since 1940. Along the side, price in dollars. Okay, so 1940, let x equal 0 represent 1940. Okay, so in 1940, it's 23,100. So these are going to be a variety of costs. It goes from 23,000 to 105,000. So we're going to go 0, 10, 20, 30, 40, 50. So we're really going by fives. Okay, and up the side, let's go by 10,000. So it'd be 10,000, 20,000. If you wanted to, you could put thousands of dollars on the side and then go by 20, 40, 60, 80. That would work. If you want to do all the zeros, you can do all the zeros. And we need to go up past 120. Okay, that should be good. Let's plot them. So 1940, which would be t equals 0, or x equals 0, 23,000. So somewhere right in here, let's change colors for that. So 23,000. 1950 would be 40,000. A little bit over that, but not much. 20 years would be 58,000. Uh, 1970 would be slightly less than that. 1980, 89,000. 1990 is just under 99,000. And then 2000 is 105,000. Okay, so you'll notice that the data kind of goes in a line, but it's just moving to the right. So what you're going to do, and now I don't know if this is going to work, I hope it does. We're going to draw a line. Maybe I can insert. Let's do this. Okay, I'm going to start at this first point and head to the last point. I'm going to make it go through though. So it kind of goes through the center of the data. Maybe let's go like this. I'm going to move it a little bit. Let's go more like that. Okay, so notice that my line might be different than yours. It's okay. What you're going to do then is you're going to pick a couple points. And you can pick whichever points you want. They should be on the line. I'm going to choose my first one, which is 0. And don't use the year again. Use the one that's on the graph. 0, 23,100. And I'm also going to use the one that corresponds with the second to last number, which was 98,500. And it was 50. Now, what you're going to do is you're going to use those 2 points to come up with a trend line. So first we find the slope, 98,500 minus 23,100 over 50 minus 0. So we get 50 underneath. We subtract them. And we get 75,400. And we reduce it. And we get 1508. Then we pick one of those points. I'm going to pick this, the second one, y minus 98,500 equals 1508 times x minus 50. We reduce those and get a slope-intercept equation. So we have negative 75,400 plus 98,500, and we get 23,100. Whoops. Whoops, what's it doing? So there's my equation. Remember that X stands for the number of years. Y stands for dollars. You might want to change that to years and dollars or whatever, but we wanted the year 2020. So what we need to do is we need to find out what year would that be. The last one was at 60 was 2000, so 70 would be 2010, 80 would be 2020. So we're going to plug in an 80, y of 80, equals 1508 times 80 plus 23,100. And we multiply that out. And we get $143,740. So I have my equation. I'm going to rewrite that as far as what it stands for. Price equals 1508 y plus 23,100. And I'm also going to change this to P then so that it makes more sense. Now the book got 148,920. Is 143,000 close? I would say it's close enough. Their line was a little bit flatter than mine, which would make it a little bit different. So as long as you show your work and you're doing the right thing, you will be okay on these. That's what students have the most trouble with, is that it doesn't match very closely, but it's okay. Tomorrow what we're going to do is I'm going to show you how to do these on the calculator, and it takes nearly seconds to figure out these equations instead of on paper. You will probably have to do the on paper version. Maybe there'll be one calculator version on the test depending on how much practice we get.